Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and we are coming in here with the classic tune, Let's Go, from the Cars. So, I suppose we should move forward on how to find the area of a triangle using sine, S-I-N-E. So let's get to it, shall we? Ooh, blank page. Well, I'm going to do a quick little, before we do any examples, I'm just going to do a quick little explanation as to where this formula comes from. So I'm going to draw a triangle, and I'm going to call it triangle A, B, C. Okay? And then I'm going to drop down a perpendicular here, and I'm going to call that N, this point right here. And I think that you would agree that the area of this triangle, well, first of all, it's 1/2 times base. And let's be honest, it's all about that base. 1/2 base times height. Okay, the length of the base times the height. Well, the length of my base here is AC. So I'm going to replace the base with 1/2 times AC. And the height right now is BN. So times BN. Okay. And then I'm going to label the sides of the triangles with the lowercase letters of the angles opposite those sides. So here's angle A, so opposite is little a. Here's angle B, so opposite is little b, this length right here. And then here's angle C, so opposite is little c. And then I'm going to call this H right here, the height. Okay. So now I'm going to say that area equals 1/2 times, instead of AC, I'm going to put little b, the length of that side, times the height. Okay. And I only need one more substitution, and that's for H. So let's take a look at H right here. Well, H is part of triangle BNC, and BNC is a right triangle because this is a perpendicular. Okay. And if this is angle C, opposite is this side, and the hypotenuse is this side. So opposite is the letter H, and the hypotenuse is the letter A. So you all know that sine is equal to opposite over hypotenuse, which means that the sine of angle C is equal to, in this case, H over A, opposite, the opposite side, over the hypotenuse, which is opposite the right angle. So to solve for H, I'm going to multiply both sides by A, and the A's cancel. And so I have A sine C is equal to H. And then I'm just going to do a simple substitution right here for H. And I get A equals 1/2 times B times, and I'm going to replace H with A sine C, times A sine C. And then to get the final formula, I'm going to get A equals 1/2 AB, just switching the A and the B here, times the sine of C. And that's the general formula for the area of a triangle. Okay. And if you just look at it real quick, I'm going to redraw this triangle. That's a horrible triangle there. I don't care. A, B, C, capital C. Little a is here, and little b is here. So for this to use this formula, you have to have two sides of a triangle, and then the angle that those two sides form. So you couldn't have this side and use angle C, but you could have this side, let's call this little c, B and C, and also an angle A and still use it. So we could also write this formula like this. Area equals 1/2 BC sine A, or if I was going to use angle B, area equals 1/2 AC sine of angle B. It's all the same formula. It just depends on which side you use. So let's do it here. Find the area of this triangle. So area equals 1/2. Let's get rid of that. Got to tutor Alex. We'll just snooze that for 4 hours. 1/2 AB sine C. Okay. Well, it's just the two sides that form the angle. Like this side and this side form this angle. So this is perfect. So this is 1/2 times 2.8 times 4.6 times the sine of 37 degrees. So I'm just going to go to Desmos here and put in 1/2 or 0.5 times, oops, I didn't get the point now, did I? 1/2, okay, 0.5 times, and I forget already, 2.8 times 4.6, so that's 2.8 times 4.6 times the sine, and I forget the angle measure. Let's go back. It's 37. So type in 37. And I'm good, but it's negative. Well, I haven't changed to degrees yet. The default is radians, and so my area is rounded to the nearest tenth, 3.9 square units. So that is equal to, oh, it's kilometers, so 3.9 square kilometers. Okay. Another example. Here we're given all three sides, but it all depends on the angle that you have. I have this angle, so I have to use the sides that are included. And this is kind of weird because this is side A and this is side B and this is side C. So actually using the formula area equals 1/2 BC sine A. Another way to think of it is whatever side you use the angle, the other letter. I use B and C here, so the angle is going to be A. Get it? A, B, C. So this would be 1/2 times 8 times 17 times the sine of 97 degrees. Back to Desmos. So 8, 17, 97. Let's see if I can remember it this time. So 1/2 times 8 times 17. I don't know if that's right. I'm so stupid. 8 times 17, good. Times the sine. I just typed that one in instead of clicking function of 97. And there we go. It's already in degrees. And so my answer is 67.5. And I don't have any units, so it's just units squared. So that would be 67.5 units squared. And then the last example, here we go, is right here, triangle PQR. And I only have, it's a right triangle, so if I had this, I could do 1/2 base times height. And I could get it using the Pythagorean theorem, but I think it's easier to use A equals 1/2 AB sine C. Okay, meaning all I need here now is angle R. And I think it's easier because I already have 90 and 51. So angle R is equal to, that's a P, angle R is equal to 180 degrees minus 90 degrees minus 51 degrees, which is equal to 39 degrees. Okay, so this is 39 degrees. Okay, so this would be 1/2, because now I have the two sides and the angle that those two sides form. So it's 1/2 times 5 times 13 times the sine of 39 degrees. And let's see what that equals on my calculator. So that's going to be 1/2 times 5 times 13 times the sine of, I forget, 5 times 13, 39. Oops, 39. There we go. Oops, I got to get inside there. 39, enter, and I have 20.5. 20.5. So the area of that triangle is 20.5 units squared. And that's all there is to it. That is, oops, that was awkward. Back, okay. That's all we got for you. Hope you enjoyed it. And let's see how the cars are doing. They're doing great. And we will see you next time. I am... Oh!